So we're here today at Bobster testing our BlueOS integration with our SPRINT-Nav products, which is enabling products like the BlueROV to be used with professional grade navigation, which means they can go out and do real work, multi-beam survey, infrastructure survey, or subsea asset inspection.
So what's great about the BlueROV is it's a low-cost remote operator vehicle which allows a wide range of integration of sensors through Ethernet and serial interfaces.
This particular model, what we've done is to add a GPS system. We've got the Voyis camera and we have the SPRINT-Nav Mini at the back. We've also got Chelsea instruments, and all these items now are plumbed through the system and can be looked on the topside computer. So if we now go to the Voyis camera, this item has been built for the Ocean Conservation Trust, and what this is, a down-facing camera. It will now look at the seagrass and it takes about 5 pictures every second. Now, because the SPRINT-Nav Mini knows exactly where it is, each picture can now be geotagged. They can then be added together using photogrammetry, and eventually a 3-dimensional model of the seabed can be produced.
What's also great about the BlueOS is it's an open source interface which allows the full control of these sensors, and why we're here today is to test our own Sonardyne extension to allow integration with our SPRINT-Nav family.
So SPRINT-Nav is the name for our family of hybrid inertial navigation systems, which combine DVL sensors, pressure sensors, and high accuracy non-magnetic inertial sensors to produce subsea navigation systems. So what does this mean for the user? Effectively, it enables high accuracy subsea navigation with distance travelled accuracies in the order of tens of centimetres after kilometres. So let's have a look at how the software works.
This BlueOS extension allows a GPS signal to be sent to the SPRINT-Nav for initialization. Upon initializing, the SPRINT-Nav will then stream HNAV data to the vehicle. This allows the vehicle to receive HNAV data. Once this data has been decoded, it allows the vehicle to update position, i.e. once you are submerged, you'll still get map updates, but it also allows you to do position delta updates, which gives you the ability to do position keeping and station hold.
So, SPRINT-Navs contain highly accurate Doppler velocity logs, which provide incredibly accurate and incredibly precise seabed relative velocity measurements. Combine that with a highly accurate inertial sensor, and you get really accurate seabed relative positioning, allowing vehicles to remain on station for multiple hours at a time with minimal error. All SPRINT-Navs contain navigation-grade inertial sensors, which measure the rotation of the Earth and use this to find north. This means they're completely unaffected by magnetic objects on the seabed or ferrous objects on the seabed. Things like the BlueROV use a magnetic heading sensor for their navigation, whereas we don't use a magnetic heading sensor for our navigation. Here you can see the difference between a heading sensor that's affected by magnetic deviation and one that isn't.
If you've enjoyed what you see today, there's one or two ways you can get this extension. If you have access to the BlueOS ecosystem, get it on their extension store. But also if you want to operate this via, let's say, to ground control, you can access this through our Docker page.